Hi everyone, my name is Tor Frick and I'm the co-founder and art director at Neon Giant, a game development studio. And I've been using Modo for more than 12 years now. And back when I started with Modo, it was the selection tools and the core modeling tool set that really drew me into Modo. But it's the customization that has really made me stay with Modo through the years. And this talk is a lot about that. And through the years, my job and what I'm passionate about has changed quite a bit. And I've worked with everything from assets and props to low poly art, LODs, tech art, and so on, to freelance concept art, art direction, technical art, and pipeline consulting for AAA games and movies. And these are some of the titles that I've used Modo on through the years. And I recently co-founded my own game development studio. We're working on our first game, which is a cyberpunk action game. This is an early screenshot. And at Neon Giant, I work with pretty much every aspect of the art pipeline on a near daily basis. Technical tools, both with Modo and together with Unreal, together with rigging and animation, high poly art, marketing art, modeling of everything from modular environments to set pieces, vehicles, characters, and weapons. And at Neon Giant, pretty much the entire process, from the concept art to the finished production art, takes place almost exclusively in Modo. And I wanted to focus this talk on addressing, different aspects of how I work and worked with Modo through the years, and focus on how I created my workflows. And as the tools have evolved and game art has evolved, and my own job has evolved, and my art style has changed through the years, I needed to change and update my workflows accordingly. Because the art I create today is much, much more detailed and intricate, but also on a much, much grander scale. So I wanted to, my workflows need to improve at an even faster rate to be able to minimize the time between idea and the finished art. And this is, my philosophy on how I create these new workflows, because I want to be able to use everything I have learned through the years in my custom workflows, but I also want to be able to take new workflows, because game art is evolving at a very, very rapid pace, and I want to be able to take whatever new, interesting, and efficient workflows and adapt them to my own workflow without losing all the customization effort that I put in through the years. So I'm not a very good, technical artist in that I can do a lot of scripting and so on. So I try to rely as much as possible on the tools that are already in Modo, as well as whatever is out there in the Modo community to be able to get to my end goal. And I try to not get bogged down on specific implementation, like, oh, this is exactly how I want to do something. I'm very flexible in how I want to achieve things in Modo. Everything that improves my workflow with Modo, is a good thing. And I often see people addressing, very specific things, like, oh, it doesn't have this feature or, this button. Instead of, I try to break everything down into what is the process that actually happens in this tool, and can I break it into smaller chunks and then solve those chunks, or did someone already solve it for me? And I try to solve each chunk independently, so that it's often much easier to find several small solutions than instead of one big solution that fits exactly what you want to do. And then I just take maybe some macros and then some scripts from the community, and I just duct tape it into my own awesome solution. And the more you know about Modo, the more ways you have to solve a specific problem. So I try to learn as much as possible, even things that are not directly at first glance very obvious to use, because, for example, I'm using procedural textures to aid me in modeling, which is not something that you would think of unless you had knowledge of those things in Modo. So I try to spend as much time as possible in getting a good grasp of all the different aspects of Modo, because you don't know when you're going to be able to use them. And that's where I have an advantage, because I have moved between different positions as an artist, and this has allowed me to see a lot of different specializations, and they're very specific tools, and then you can apply them to things that they were not at all intended to. So back when I started using Modo, I was very much doing production work, and I was doing high poly and low poly modeling, baking to assets, which was very cutting edge back then. But it wasn't it wasn't a very a great way to do 3D design because you have to do the sub-D modeling properly, and all that takes time, and it's great for production modeling, but for doing concepts, it's quite time consuming. So back when I started doing regular sub-D stuff in Modo, I was focusing on speeding up the process of doing that, making new tools. For example, when I'm adding support loops in Modo for something, I just added all those loops back into a selection set. So back when I wanted to create a low poly model, I could just instantly select all the loops that I added and then just delete them, which was was a huge time saver for doing something like that. But then they introduced the edge weighting, and you didn't need to do that anymore, and you could adapt your workflows to that, which was fantastic. But it was still a limitation on how much design iteration you could do, especially when you're on a production time budget. And I didn't really have a way around this until the round edge shader happened, and that was a huge game changer for me. Suddenly, 3D concept art became a lot more viable in Modo. So this mech here is made like 100% with the round edge shader. It's pretty much only low poly geometry, and this really started to allow me to bridge the gap between concept art and high poly and in-game art all at once. And it was really meant for smaller scale things. Like really small edge highlights, but I just abused it and just cranked it up, like way higher than you're supposed to, and it still very much works, especially when you're making your grungy sci-fi things like this, where you don't focus on any small imperfections, but you can't really tell that this is not actually smooth geometry. But there was always the problem that it's a bit abstract, for an artist, because it's not direct in that you see the highlights the same way you do in sub-D modeling. So I tried to get away around this, and the way I do that is that I have a setup where I'm toggling off a lot of things in my material tree, and I have a very simple rendering solution. I also toggle off everything that is expensive, so I can run a near real-time preview of what the render will look like, even on like a complex model like this mech, which is still relatively light because it's essentially all low poly geometry. But doing this allows me to have very complicated materials in my shader tree, but I can still just toggle them on and off and be able to use it like non-destructively and preview all these complex shading from the round edge shader without having to go back and forth between different setups. And now I could suddenly use low poly geometry for high poly art, for simpler shapes, such as this. And it doesn't work with sub-D geometry because the way you work with this, because you don't care about the topology anymore. But it's very, very fast to clean up and bake down. Like this corridor is 100% round edge shader geometry, then just bake down to the low poly. But it's not fast enough as a workflow improvement. So you can suddenly use Booleans because you're using low poly geometry, and you don't have to care about the topology. So what I wanted to do is have faster Booleans, and Modo's Booleans create very clean geometry, so you can use the same mesh both for the low poly and the high poly mesh. You don't really need to do a cleanup, so you can really go crazy and just do excessive amounts of Booleans. So I needed to speed up that process. So this is a real-time cinematic from Unreal 4 that I made, and this is essentially low poly, high poly design mesh. It's all the same. There's no distinction between the different aspects of the production. So it's pretty much 100% automated in that I create a selection macro for making the UVs, which I then clean up a little bit, and I bake out the textures from the mesh to a copy of the same mesh, and I do the textures automatically in the Quixel suite. So essentially, the design mesh and the final result in-game in real time is the same mesh. There's like no distinction between them. And this is really when it starts to fulfill my criteria, of going from essentially the concept art to the final production art in-game without any steps in between. And this is an example of the, how the meshes work. So the mesh on the left is the mesh that is used with the round edge shader. And on this version, the hard edges is a design choice because you want to be able to choose where your highlights are going to appear. But at the same time, on the middle version, it's all smooth because when you're making a game art mesh, you want to minimize the vertex count. So I just duplicate the mesh, and then I'm doing a selection macro, and I clean that up a bit because I'm obsessive and I can't help myself from optimizing. And then I just unwrap that, pack it automatically, and then I bake it from itself down to itself, and you essentially got an optimized, good-looking, well-shaded in-game mesh with no, essentially no handwork whatsoever. And this allows you to, and since there's no technical component to the modeling, you can just Boolean whatever you're doing. So, even as a concept artist with no technical requirements, you can just go crazy and you can just do whatever you want, and you just bake that down, and it's an optimized in-game mesh, and it just works. So the way I achieve these faster Booleans is a good example of what I was talking about earlier about breaking something down into smaller parts. So I wanted to Boolean things really quickly in one layer in Modo. And at the time, it didn't support that because you needed a watertight geometry, and the Booleans were using in several different layers. So I took Seneca's quick Booleans, which uses, so you can Boolean things in one layer. And then I just took my selection, saved it to a selection set, saved what was under the mouse to another selection set, and then I just hid everything else so that Modo thought that nothing else was in the layer. And then I could just do Booleans and then, I just made that into a quick macro, and I did another version where I'm doing a complex panel, which is essentially doing the same thing, but twice. So it's doing one union Boolean and one subtractive, like one intersect Boolean and one subtractive Boolean. And you can essentially make these panels really, really quickly. And it's all put into one macro. And this way I just work around the limitations that you have, and I create a macro out of it. And essentially, when you're doing this, it looks like the limitations were never there to begin with, and people thought it was like, oh, this is auto magic, it's a new tool. And it's like, no, I just broke it down into this logical steps, and I used very simple tools and macros that anyone can use, and then I just created a new tool for it. And another aspect of this is the materials and the rendering. And it started out with me just wanting to present your high poly models better because it looks cool and all the cool kids are doing it. But for most artists that are in production in game art, this doesn't actually bring them anything. Like making nicer high poly model renders is just good for your portfolio. We don't really use it in production. But it's a bit of a missed opportunity because there are a lot of things that you can do with materials that are not quite obvious. So for example, I'm doing my cables using the procedural textures in Modo, and it allows me to do complex patterns and so on cables automatically, which I then save out as presets, because all the tubes in Modo have UVs by default. So you can just slap things like this on it, and this is a very simple example where it works. I also do things like having the wear and tear automatic, and you can bake that down, but you also use it a lot in production art, and like in concept art, because it allows you to do things like very dirty models, and you can get an appreciation for how it will look like when it's finished without actually having to do any manual work while you are designing the mesh. And this is very useful, because if you're only doing clean, very clean, stylized things, it's fine. But if you want to do really dirty, gritty things, you don't get an appreciation of how it will look like unless you can preview it. And this way I can preview it, and then I can bake it down to the final mesh, and I get the exact same result. This is another example of just doing this same thing. And another thing that I do is that I have a unified naming convention for everything. So when I drag drop meshes and new materials into the scene, they will just work, because when you are adding like a mesh preset from Modo, it duplicates all the materials because it needs to know what materials it's using and so on. So what I ended up doing was I just deleted all my materials from all my presets, but the material tagging system still works, so I can just drag drop whatever materials or whatever preset meshes I have, and they will just get like the detail, chrome, applied to it, it will get like the base metal and so on. Everything will just work just by drag dropping it into the scene, and it saves me a lot of time when doing very quick, design iterations. For example, the cables they're just a simple tube that I just then drag dropped a preset for a cable on. And this is another example of just the same thing where I'm using, material presets. And for example, in this case, I was doing a lot of the decal work by rendering it out and then painting just painting directly on it in Photoshop and then reprojecting that back onto the model. And that way I can do all the custom little, doodads on it and like little decals and like whatever I want. I can just paint that on straight into Photoshop and then just reproject it into the right rendering layer. And then I have something that I could bake down to a finished low poly game mesh without actually having to do, anything. So back to the modeling. So the mesh ops, when they were introduced, I couldn't resist because it's non-destructive booleans, which is too awesome to avoid. And I really wanted to implement it into my workflow, and I came up with some solutions. So I was doing these live streams where I'm doing 1 mech per day, and what I did there was that basically it takes so much time to well, it doesn't take that much time, but it takes time to set up the booleans every time you're doing them. So what I ended up doing was a preset assembly that I can just spawn into Modo with a hotkey. And that really started to unlock, more design experimentation that is non-destructive. I could just drag things around, see how they worked. But it still was a bit limited because I was still limited to low poly geometry, and I couldn't do a lot of the things that I want to do, like lots of round shapes, really like complex shape exploration. But it was very, it was a very good start, and I used a lot of, help and ideas from the Modo community, and just used that to, build this first version of the tool. And that's where, my design style has, really evolved to something that is not, not easy to work with because it features a lot of very complicated shapes that are intersecting. And this is where MOP Booleans came in, and William was doing a fantastic job on this. And I was super happy to be able to help him with him. And this really started to unlock, like, I could suddenly have a fusion of all my previous workflows where I can use, sub-D geometry with weighting, excessive abuse of the round edge shader combined with, non-destructive booleans and the round edge shader. And what's really cool about this is that it really unlocks a layer of exploration that you don't really have otherwise, because when you're doing things like some simple subtractive booleans, you can really, you're gonna subtract a circle or whatever, what's gonna happen. But what you can't do is that you can't really do these complicated intersecting multi-layer booleans where you can just take these really complicated like objects like sub-D geometry, mixing it with low poly geometry, doing a intersect boolean, and then like 3 layers of subtractive booleans, and you're just dragging things around, and you're just exploring all these complicated mechanical shapes in real time. And at the end, you get a very optimized mesh, which you can just shove into a game engine. So something like this, really quick, just takes like a minute, and you can just, I don't know what this is, but I built it. So this is another example of me taking a mesh, using the same workflow a bit further. So I just started out with really low poly geometry, starting blocking things in, and then gradually just refining the shapes, turning them into sub-D geometry, and still just retaining the non-destructive approach with the booleans and the MOP booleans, and just splitting things up into more and more detailed parts, and just iterating on basically the same layers the whole way through, and then just having the automatic shaders on it. There's no hand texturing here. Everything is just 100% automatic, and you can just bake this down into like a relatively quickly cleaned up low poly version of the same thing, and you have your finished gun. So at Neon Giant, I used MOP Booleans for pretty much all my design work. And the art style features a lot of intersecting round shapes together with complex mechanical parts, cable work and pipes tracing the complicated things. So I need to be able to design things really quickly. So for example, this robot there was pretty much made from initial idea to finished in-game model in a couple of hours. And it's really starting to hit the point where I can do complicated design work and be able to get it in game in a very, very short amount of time. And I'm always trying to push things a bit further. And for example, this is I'm trying to explore some how to take this into next steps. How can I achieve a even greater amount of detail? Because the trick is you want to be able to work really without creative limitations, but also produce things that are very, very detailed and very, very technical. So this is one of my mechs from my one-day mech streams, and I wanted to use this as an example when I try to explore a new workflow. So I basically took a zoom in on the legs of this mech and started to create a new workflow where I can leverage the MOP Booleans, the round edge shader, and the new awesome automatic vertex normals in Modo, combined with the new mesh painting, for example. So, and then you zoom in. This is like from real-time shots from Unreal. Just trying to see how far I can push the cinematic aspects while still having a live design model. So I'm basically designing something in Modo, and I just push it to Unreal, and it just automatically looks like this. And then just doing a CSI style enhance, and just seeing how far you can push this by just leveraging all the different aspects. You have the UV, you have the UV mapping and tools in Modo. You have different kinds of baking things down. Using the shader tree, and just trying to leverage like all those things. And I could never be able to create this is still a workflow that is really fast, but I created it without any custom scripting. It's all few macros, and it's mostly just the fact because I have experience of using all the different aspects of Modo, and I can leverage them all at once and just do things that are not exactly obvious if you're just a modeler, but really allows you to leverage things. And yeah, that was it. Thank you.